In today's video, you're going to learn everything you need to know regarding promises in JavaScript. First, we're going to talk about what a promise is, and then we're going to talk about how to create promises and different ways to handle promises and some examples of doing so. So first off, what is a promise? Well, a promise is a placeholder for a future value. They allow you to perform asynchronous tasks within JavaScript. So for example, let's say that you have a network request that takes a significant amount of time. Well, JavaScript is a single-threaded language. And if you had to wait for that network request to completely finish before doing anything else in your program, that would likely slow down your program significantly. And you can imagine if you had several network requests, well, that would make your program's user experience quite terrible. So a different way to handle this would be to be like, hey, okay, I want to kick off this network request to occur here. And when this request completes, then I want to handle whatever value it comes back with. So let's say that you're going to go get data from your database. And then once that data comes back, you want to do something with that data. Well, this is what you can use promises for. The promise is going to be a placeholder for that data that comes back. So you can kick off the network request and then you can create a promise. And this promise is just going to represent, okay, we don't have this value yet, but once it comes back, then we want to do something with this value. And that promise is going to be kind of that placeholder for that value that it isn't here yet, but it's going to come in the future. So a promise is a placeholder for a future value, and it allows you to perform asynchronous tasks within JavaScript. Now, the actual representation of a promise in JavaScript can be thought of as just kind of a basic object. Now, every browser might have a little different implementation of like different types of promises and what's going to be on a promise when you do a fetch request and something like that. But you can use it very much so just like a JavaScript object. And a promise has three different states to it. So there's kind of three different statuses that a promise can have. And these are fulfilled, rejected, and pending. A promise is fulfilled when the data comes back to the promise, and now it has the expected value. A promise is rejected if some error occurs while you're trying to get the value. So if you make a network request and that network request fails, well, that is going to result in a rejected promise because there was an error getting that data. And then a promise can also be in a state of pending, meaning it doesn't have the value yet. So you make the network request and that request is still being made. It hasn't rejected, it hasn't fulfilled, it is still pending. Okay, so a promise is a representation for a future value. It's represented as just a JavaScript object and it has three different states. Fulfilled, meaning the value has successfully returned to the promise. Rejected, meaning there was some error when trying to get the value. So like a network request, it failed and the promise is now rejected. And then pending, the promise hasn't resolved with a value, nor has it rejected. It is still going to get the value in performing that task. So how do you actually create a promise? Well, one thing that's important to remember is that you don't always have to explicitly create a promise to do this within your applications. And some functions return a promise automatically. So like the fetch function that you get to use automatically in JavaScript, that will just return a promise by default. And you don't have to explicitly create a promise and return it from fetch. It automatically returns a promise. Same thing with asynchronous functions. So when you create an async function within JavaScript, it's automatically going to return a promise. So there's certain functions that will automatically do this in which you don't need to explicitly create a promise. However, it's still definitely important to understand how they work. All right. Now, you can also manually create a promise. So if you want to perform some asynchronous task in your program, you can create your own promise and then either resolve or reject that promise depending on kind of what occurs while you're getting that value. And the way that you do that is you can use the promise constructor within JavaScript. So to create a promise, you can use the new keyword, and then you can call the promise constructor function that you get for free within JavaScript. You don't need to create this class or anything like that within your programs. You get this for free within JavaScript. And what you can do with this promise constructor is you can pass it a function. So here, I am passing this promise constructor an inline anonymous arrow function. It doesn't necessarily have to be an inline anonymous arrow function, but this seems to be the most common way that you'll see this done. So here I am passing a function as the argument to my new promise constructor function. And what the promise constructor function does is it's automatically going to pass me two different arguments to my function that I pass in as an argument to the promise constructor. And these two arguments are going to be a resolve and reject function. So argument number one to my inline function that I pass in here is resolve. And this is a function that allows me to resolve my promise. And then the argument number two is reject. And this is a function that allows me to reject my promise. And then within the body of my function here, I can write some logic and then either resolve or reject my promise depending on different things that happen. So in this example here, in the body of my inline function, I'm setting a count variable to 5. And then within the body of this function, I say if my count is less than 10, I want to resolve my promise. Else, just reject it. And this new promise constructor here, it's going to return a promise. So I'm assigning my constant p to be a promise that's returned from new promise. Okay, so this is going to be a placeholder for my future value. And it's either going to resolve or reject my promise depending on what happens here with my count. Now, how can we handle when our value either resolves or rejects? Because right now it's just a placeholder for a future value. Like if I made a network request, well, I don't have this value right away. So how can I perform some action with the value that comes back? Well, that's where you can use the functions .then, .catch, and .finally. So on a promise object, you can access three different methods, .then, .catch, and .finally. And those allow you to handle your promise value when it either resolves or rejects. Looking at it here, the way that these work is I use my promise and then I access the .then method on my created promise here. So I do p.then. And then what I can do here in this .then method is I can pass it a function. And this function is going to run when my promise fulfills. So here I pass in an inline function here to my .then method, and I console log my promise, and I just console log the string fulfilled. And this .then code, it only runs if your promise fulfills. It will not run if your promise rejects. So if I comment out my .catch block, which I will cover in just a second, and I just run this .then code, and if we look at the logic of my promise here, well, my count is 5. That is less than 10. So my promise should resolve here. And that is going to run my .then block because .then methods are going to run the function that you pass into them once a promise resolves. So if I run my code here, you're going to see that my promise is undefined because my promise really doesn't have a value to it. Like I don't resolve my promise with any value, but I'll show you that in just a second. And then I get console logged fulfilled. So I do run this block of code. And you can see this promise is represented by just an open pair of curly braces, just a JavaScript object. Now let's handle if the promise rejects. So the way we can do this is we can use a .catch block because you're catching the error that occurs. So your .catch works the same way as .then does. And I'm chaining my .catch onto my .then here. It might make it a little bit more clear if I just put it right here after the closing parenthesis of my .then block. And the reason I can do this is because the .then and .catch methods, they return a promise themselves. So .then automatically returns a promise, which allows me to just kind of chain on my .catch block. Okay. So .then and .catch automatically return a promise themselves, which allow you to do this kind of chaining of promises here. And the way that .catch works is the same way .then works. You pass in a function to run when your promise rejects. And it's important to remember here as well that .catch it only is going to run if my promise rejects. It will not run if my promise resolves. And the opposite is true for .then. It only runs when my promise resolves. It does not run if my promise rejects. So in my code right now, my logic will still make my promise resolve, which means that we won't run this .catch block yet. So you can see I just get my promise, it still has no value, and then I still get my fulfilled console log statement. But if I change my logic here and I set my count to 12, well, now my count is not less than 10, so it's not going to resolve here, but it's going to reject. And what's going to occur here is once it rejects, well, I'm not going to run any of my .then functions, so I will not run this passed in function to that .then, but I will run my .catch block. And if I run my code, you see that my promise, it now has this kind of rejected marker to it, and I console log out rejected. So this represents a rejected promise, and I console log rejected because my .catch block is what will run when a promise rejects. Now, there might be a situation in which you want to run some code regardless of whether the promise resolves or rejects. And that's where you can use a .finally block. So .finally, you can chain it on to your .catch and .then blocks, and this is going to run no matter what. It's going to run if your promise rejects, and it's going to run if your promise resolves. In either case, your .finally block is going to run. And I think that a very common example of this is like if you're making a network request, you might have some state in your program that is set to loading. So you're loading that request. You don't have anything to show the user yet. But regardless of whether your request fulfills or rejects, you're going to want to set that loading state to false in either case. And this is where you might use a .finally block. In either case, your request is done. And you can set your loading state to false. All right, so let me show you here an example of this working. So my promise is still going to reject here, but I would expect us to run this .finally function that we pass into .finally. So the API of .finally works the same as .catch and .then. You pass it a function to run regardless of whether the promise resolves or rejects. So I would expect this code to run even when I have a rejected promise here. And as you can see, it definitely does indeed run. It console logs my promise, which is still going to be rejected. And then here it console logs finally because we enter this finally block. And then also since my promise rejects, we definitely run my .catch block as well. Now, if I change my logic so my promise resolves here, you're going to see that my .finally block still runs, but it's going to run after my .then functions run. So here I run my .then block, which is console logging fulfilled, and then I still run my .finally block. Okay, so .finally, the functions you pass to it are going to run irregardless of a promise resolving or rejecting. Now, I already talked about how .then and .catch return a promise, which allow you to kind of chain on these promises here. So I could even chain on more .then, so I could do .then, perform some action, that's going to return a promise, and I could add a .then to that and kind of continuing down that chain. All right, so .then and .catch automatically return a promise, which allow you to chain on the .then and .catch methods. Because if it returns a promise, you can access the .then methods on the returned promise. Now, promises, they often resolve or reject with some value. So a promise might reject with an error, some object representing that this whatever task you try to perform, it didn't work. It resulted in an error. And then they might resolve with some value. So if you make a network request and that data comes back successfully, well, it's probably going to resolve that request with that data. So in my logic here, and I'm going to get rid of my .finally function just to make this a little bit more clear. I'm going to resolve my promise here with a value. And here, I'm going to just resolve my promise with a string resolved. So how do I access this value within my kind of .then block? Because my .then block, it's what's going to run when my promise resolves. Well, if you resolve a promise with a value, you can access that value as a parameter to your passed in function to your .then method. So here, I can accept a value as a parameter. And instead of console logging fulfilled here, I'm going to just console log whatever value is resolved by my promise. So I'm resolving my promise with this value here, which is automatically going to be passed in to my .then method, which I just console log out here in the body of this function. And if I run this, you're going to see that when I console log my promise here, so on line 54, when I console log that, my promise, it actually shows a value here. It has the value of resolved. And then I also console log my value, which is resolved, because it's automatically going to be passed in as an argument to my value parameter, and I just console log that out here. And you can imagine that this is going to be very useful in the case of network requests as well, as when that data comes back, well, you probably want to do something with that data, and the way that you're going to do something with that data, or the way you're going to access that data, is it's likely going to be passed automatically to your .then method, just like this is here. So like the fetch method, it will automatically resolve your promise with the data that comes back from your network request. And that data can be accessed right here. So in a network request, this might be an object of data, and you might access your value right here, and then you could perform some task within your .then method because that data was resolved in your promise here. Now the same can be true for the reject method. You can reject a promise with some value, and I can access it the very same way here in my .catch method. And I'm going to just console log my value here. And if I make sure my promise rejects here, and I run this, you can see my promise, it now represents a rejected promise. So I'm console logging my promise here, and it is now rejected, and it has the value of reject because I reject my promise with the value of reject. And then I also just console log my value here on line 58, and that yields reject. Because when I reject my promise, it works the same way as resolving it. I reject it with this value right here, which is going to be passed in as an argument to my function that I pass in as an argument to my catch method. And then I just console log that value right here. So that gives you the fundamentals of promises in JavaScript. Now, there's definitely more to talk about when it comes to asynchronous JavaScript. I'm going to have future videos on the promise.all settled, and those different methods that can kind of work on promises. And then we're also going to touch on async await, the event loop, and different things like that. So I hope you enjoyed this video and learned a ton about promises here. Let me know below if you have any questions about promises, and I'll catch you in that next one.